Hi everybody. This lecture is on methods. This should be for the most part review for you, but I wanted to take a little bit of time and actually re-unpack the idea of methods and what it means to have a method and declare a method and why you need methods, and just really kind of drill home and drive home that concept of a method. I'm also going to talk about static methods and how those are different from traditional methods. And then the last thing I do want to talk about is the concept of delegates. And delegates are important because they facilitate things like event handling, and in the future, as we start talking about events, how those pieces kind of work and interact together. So the first question may be, why do we make methods? What is the purpose or the point of making a method? Well, everything that you do within the C# language is done within the scope of a class. So every form, every console application, anything that you do, any code that you write is written inside of a method that lives inside of a class. So it's kind of the fundamental building block of object-oriented programming that you use methods. But the reason why you would want to use more than one method is to make your program modular or kind of isolated or self-contained. So you're going to kind of, as you're thinking about building your program, you want to think about what are pieces of functionality that I can write, what are lines of code that I could write that could stand on their own. They could kind of live in their own little module. They could function independently and live on their own. The most simple example I always like to think of is when you're writing a calculator program. Well, you would write a method to do addition, you would write a method to do subtraction, you would write a method to do multiplication, and you would write a method to do division. And each one of those methods would take in two parameters, which would be the numbers that you would want to add, subtract, multiply, or divide, and then it would return a value or a number that would be the result of that calculation. So that idea of making it modular where that addition function can essentially stand on its own and be called, and it becomes reusable, which is the second point. So we could call that function over and over and over again without having to write the same lines of code over and over. So whenever you are writing your program, and this is a rule of thumb for myself, and you find that you're writing the same few lines of code over and over again, you may want to take a step back and reconsider, is it possible for me to take this chunk of code, whatever it may be, and wrap it into its own method, passing in whatever appropriate data is necessary and then getting back my result? So those are kind of things to just keep in the back of your mind as you're writing code. If you end up writing the same code over again, or you see an opportunity to kind of isolate and modularize some of your code, I recommend doing that. Now, what does a method look like? What I have here for you is kind of some basic code here. We have a public class called user, and inside of this I have one method. This method is called getManager. Now this method has four basic parts. It has a scope, in which case this is a public method. So that means that anytime there's an instance of my user class, I have a user variable out there, I have access to call getManager because it is a public method and it's available publicly to any other piece of code that may be using this manager, or I'm sorry, using my user class. There's the return type. And the return type helps to identify when I call getManager, what will it be giving me back? Is it going to be giving me back a string? Is it going to be giving me back an integer? Is it going to be giving me back a more complex type, such as a user? In this case, whenever I call getManager, what will be returned back to me is a user object that represents the manager for the user in question. So if you think about how this would work, is you would have a user variable, and that user, maybe it represents yourself. Okay, you're the employee. There's a method off of your user object or your user record that's called getManager. And when you call that method, it performs a lookup and says, okay, you are the employee, you are the user, And associated to you is a manager, and it's this person. We'll call him Steve. Um, Steve is your manager. Therefore, we're going to go and get the Steve user object or record of data, and we're going to then return that user object that represents Steve as the manager in relationship to you, the user. So that's the general mechanics. So get manager is the actual name of the method, and then the last part, which is bool top level, are the parameters that are passed into the method. Now those parameters are passed in because they can then control or kind of help guide the method in what action it should be taking. In this case, if we say true top level manager, then this method would kind of walk up that manager chain in theory and find the highest level manager associated to the user that you're acting on. If you did not pass true, if you passed false, then it would only pass the next highest manager, Steve, as we talked previously, and does that work that way. So you're helping kind of dictate or drive the get manager method by passing in these parameters. Other cases where you would pass in parameters is if you had a method where you were going to fetch all users. If you were going through the process of fetching all users, then you would actually probably pass in maybe a department so you know which users to grab. There could be a number of different other things that you could do. You could pass in a user ID if you wanted to go get a particular user. So those are all different types of situations where you use parameters. So how do you actually call a method? Well, like I said before, a method is always wrapped inside of a class. So a class, if you remember from our first week, is basically two things. It is a construct that defines an object. It talks about what things does this object do, what data can this object hold or its properties, and every class is a data type. So just like you have strings and booleans and date time and integers, you also have these classes. So this little block of code that you're looking at right now is what you would see in any basic C# console application. This is your static void main entry method to a console app. The user u equals new user is the instantiation of a new user object. So we have a user u. U is the name of the user variable, and then on the second line we are calling u, the user object, dot get manager, which is our method that we just saw previously, and we're passing into it true as a parameter. What it's returning back to us is a user object that we're then storing in the manager variable. So if you think about this again, so we're calling get manager, its name. The return type is a user, and we passed in a parameter saying true. We want the top level manager. So these pieces all work and kind of interact and work together to help us understand how do we call this method and what does this method do for us. That is a method that we created for our user class. I also want to talk for a minute about static methods. Now, what is a static method and how does it differ from a traditional method? Static methods generally look exactly the same as instance methods, which is what we looked at previously. The one primary difference between a static method and an instance method is the keyword static that appears between the scope and the return type. Now, what a static method does, or what it means to make a static method, is that this method can be called without creating an instance of our class. So if we look back real quick at how we called the previous method, we first created an instance of user. We called it u. So u equaled a new user, so we have now a user object in u. And then we said u.getManager, and that called the getManager method. Now, comparing that to our static method, which is called getAllUsers and returns an array of users, we can actually call this method without creating an instance of a user. We actually will just use the user class and call this method as a static. So what does that look like? Well, here's a similar instance of our static void main method, but now what we do is we create a variable of all users, which is an array of users, so that's kind of our catching variable after we call our method. Now notice that we're not creating an instance of users anywhere, and then on the next line we say user, which is our class name, not a variable name, but the class name, user, dot get all users. And what this will do is it will execute that static method without creating an instance and return us all the users out of our data source, be it a database or an XML document, whatever that may be. So that is really the fundamental difference between a static and a instance method. Now you may wonder, okay, when do I need to use a static method? Static methods often come into play when you're doing a particular action that does not require context. And what that means to you and I is when we call a method like getManager, we're calling that based on the user object that we have. So if we're holding on to a user that is our own employee record and we're saying get our manager, then that method is running within the context of me, the employee or the user. But calling get all users, doesn't matter which user I have in context. More importantly, it works without having any real context around a user because its intention is to go out and get all users that exist in the database. So when you start to think of when do I need a static, it's usually when you don't have a particular context to work within. You're just trying to perform an action. Normally it's a data retrieval or some sort of a data manipulation where you'll be passing in parameters and having it perform certain actions. Alright, the last thing that I want to talk about are delegates. Now, delegates are here to allow you to create variables that point to functions. So the idea is that can I create a variable like I did previously with users u, and can I then put inside of it a function? Now that may sound a little weird, but the idea is that I want to be able to take a function and then pass it around into other functions or store them in properties so that they can then be called by other things later. So having this ability to dynamically pass and move functions is a goal within a programming language. It's the idea, the broader term is called dependency injection. So if you're able to take a concept or take a piece of code and inject it into another piece of code, you can actually dictate or control what that second piece of code is doing by passing a function and saying, in order to do this task, use this function or use this method. You'll see this in the next lecture when we start talking about events. Events hinge greatly on the idea of delegates. What an event is when a particular thing happens in your code, for example, a button click, you want a function or a method to be called. Now we always call those event handlers, but they're really just methods. And what we do with those methods is that we assign them to the event and say, when this event happens, give me a call. Call me on this method, and I'm going to do something when that event occurs. So when the button is clicked, call this function. This function being my handler, which will maybe pop up a box, or perform some calculation, or connect to a database, or go fetch a web page. Whatever that action is that your method is doing, it happens when the event takes the delegate, which is your event handler, your method, and calls it. Alright, so how do we go about defining these? Well, to define a delegate, you have to identify what's called a method signature. And the method signature consists of two pieces, the return type and the parameters. So this is a delegate declaration. So we have a scope, just as we did previously. We have the keyword delegate. This is identifying that this is a delegate declaration. We have the return type for the function or the method that we want this delegate to handle or accept. Then we have the name of the delegate. We're calling this the manager loader delegate. And then there's a parameter where we're taking in a string that is the user ID. So what we need is we need a function that takes these parameters. Now to actually assign our method to a delegate variable, we're going to go through the following steps. So the first line, user u equals new user, I'm creating another user object. I'm going to use that user object in a moment. The next line, I'm actually declaring my delegate and I'm assigning it a method. So looking at the anatomy of this, we have manager loader, the name of our delegate, which is treated as a data type in this variable declaration. And then we have a variable called ML. So we have a manager loader variable, ML, and we're storing in ML the function getManager. Now, the function getManager has this exact signature of it returns a user and it takes a string, user ID. This is an instance method off of the user object. And then what we're able to do is the third line of code where we can say user variable mgr, so we create a new variable called mgr, and then instead of calling u.getManager as we would traditionally have done, we can then say ml and then passing in the string for the manager ID 1 2 3 4 5. So that is perfectly valid code utilizing that delegate. So we actually are taking the getManager function that is hanging off of the user object, and we're storing it inside of the ML variable. And then on the third line, we then go ahead and call ML, which really is just pointing back to u.getManager, and we're passing the string 1 2 3 4 5. That getManager function runs, does its work, and then returns back a user, which we then store in the user mgr variable. I hope all of this has been helpful in kind of identifying the concepts and ideas behind methods. You'll be utilizing a lot of these features as you go through and build your application. One piece that you'll actually be using very extensively without really realizing it is this idea of delegates. And delegates come in very handy when you get into very sophisticated programming scenarios. So it's always a good thing to at least be familiar with them if you're not totally comfortable with them, because knowing at least how they work and what they are becomes a very big value add when you get into a scenario where you can at least comprehend the need for a delegate. Thanks.